Bismillahirrahmanirrahim. Today I am going to explain the electrophilic addition reactions. Any entity which is an electron deficient carries positive charge, and such entities are supposed to be called as an electrophile. When they come closer to molecules which has extra electrons, which are electron rich species like alkenes or alkynes, they can get electron from the systems and they can get added on such systems. That is why they are called as electrophilic addition reaction. See what happens, we have an idea. The pi bond is due to two electrons. So one of the electron from here, either this one, let me call it carbon A and the carbon B, from the B or A, any one of the carbon can be taken and given to this electrophile. If you just consider the two ends of a marker, black ends as an electrophile, let's say it's a bond between carbon and carbon. This electron from here, like this, will be taken and given to this electrophile. So what could happen over here? This, we will have, as I've just told you, it's an A, it's an B. This electron has been taken and this electron is given to this electrophile. So due to the acceptance of the electron, the proton, the positive charge will disappear, and then there will be a bond between this carbon and this electrophile due to the presence of electrons. So there will be a new bond between carbon and the electrophile. As we have an idea, one of the electron has been taken away from here. So consequently this carbon will be a positive charge. So what can happen in the next step, any species having negative charge, any entity having negative charge can give electron, donate electron to this carbon, and they can develop a new bond over here. So what is going to happen over here? Carbon A, here is the carbon B, here is the electrophile, and here is the nucleophile got added at the carbon B. So this is how the electrophilic additions take place at alkene and alkynes. When an electrophile comes closer to such system, what happens? One of the electron, either from B or from A, is taken. I can go the other way, the case number 2. Let's say this electron from A has been taken and given to the electrophile. What could happen then? Here is CH2, B carbon, here is carbon A, here will be the electrophile, in this case this electron has been given over here, this will be given to this one, okay, then there will be balance of electron charges, and then there will be a new bond. So we can have electrophile at carbon B. So what happens? The electron from this carbon has been taken, so it will carry a positive charge. As I've just explained to you earlier, any entity having a negative charge can attack at the carbon to donate electron and to develop a new bond. So CH2, which is A, that will also carry a nucleophile, and here is an electrophile at carbon B. You can see over here electrophile is at carbon A, over here the electrophile is at carbon B. So both conditions are possible under certain circumstances. What those I'm going to explain those. So at the beginning, electrophilic additions, electrophile can come closer to such system which are electron rich. So one of the electron from the two electrons which are bonded in pi bond, one of the electron either from carbon A or from carbon B could be given to the electrophile, and then there will be a development of a bond between electrophile and the carbon, and the carbon which has given away its electron will carry positive charge. So in order to neutralize this positive charge, somebody having negative charge can attack and get added on that carbon. It could be B, it could be A, so both are possible. So this is the basic concept behind the electrophilic addition reactions at alkenes. I can explain it a bit further now. The alkenes could be, we can write, systems differently. This is an alkene, it can undergo reaction with this sort of an electrophile. We can have an alkenes of this sort, you can see, they can go reactions with electrophile. Similarly, we can have alkenes of this way, and they can go on undergo reaction with electrophiles. So an alkene can be a very simpler one, an ethene, or it can be some sort of this sort of a compound, or it can be a bit more complex. This is also an alkene. You don't need to get worried about the benzenes, you need to focus at an alkene. The alkene can be of this type. Further, it can have any type of substituents, we can put in place in substituent like this. Okay, so it can be a simpler alkene, or it can be a complex alkene. So there can be a different forms of alkenes around, but you don't need to get worried about the type of the alkene, the complex nature of the alkenes. Whatever the type, you have an idea what is the basic concept. The electron from the two carbons, one of the electron will be given to the electrophile. Let's say this is going to be given to the electrophile, so its positive charge will be balanced out. Then there will be a bond formation over here. So consequently, what has happened, there is a bond formation between electrophile and the carbon, and then this carbon will bear positive charge. This positive charge will be neutralized by somebody having negative charge. So something like that, we can have this sort of product, electrophile at the carbon over here. 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons. Carbon number 1 electron file over here, and here is your nucleophile. So this is sort of a product, So similarly over here, similarly the other alkenes can be made to react with electrophiles, and they will undergo nucleophilic addition reactions, new electrophilic addition reaction. Now let me explain one thing which is important, Let's say we have this alkene. I can draw, let's say this way. This is an alkene, and I can write the bit simpler way. This will become CH, this will be the CH, and this will be the CH3, I guess. Can balance out something like that. So here is an alkene. Okay, let's say we have HCl that is going to react with this body. We have an idea in HCl, this is going to be a positive, this is going to be negative. So positive species is supposed to act as an electrophile. So this electrophile will come closer to this system to get add, We have an idea over here that this is the bonded 2 electrons available. As I've told you previously, we can call it carbon 1, carbon 2, this will be carbon 3, this will be carbon 4. Okay, so either electron from number 1 will be given to the electrophile. So let's see, if we give this electron from here, from the 1, what happens? It will gain the electron, it will become negative, it will become positive. So one of the electron has given to over here, then what happens? They will make a bond, mean this carbon and this hydrogen will make a proton, will make a new bond. So you will have a CH2 over here. So what has happened? This carbon has lost one of the electrons, so consequently will be a positive charge. Will be a positive charge, then this chloride can attack over here. So what is going to happen? I can write CH3 over like this. We have CH2 over here this way, or we have CH2 over Cl. So Cl got attached at the carbon number 1 and the proton got attached at the carbon number 2. This is one of the case. Okay. The other one was, what was that? Let me explain it again. Or it could be the possibilities over here again. Here is the pi bond. Let's say again we have HCl from outside. The other way could be the electron should be taken from here and given to this body, and there is a bond between this carbon and this hydrogen over here. Consequently this will be a positive charge, then a chloride can attack over here. Okay, so consequently what is going to happen? We will have a chloride here. So in one condition the chloride is going to be at carbon number 2, and the other condition the chloride is going to be at the carbon number 1. What is appropriate? It happens actually according to the Markovnikov rule. The addition of electrophiles actually happen according to the Markovnikov rule. What is that? According to that rule, if we have a molecule, let's say we have an HCl, here is positive, here is negative, this is an electrophile. According to the rule, the positive part mean electrophile will come to that carbon, 1 carbon, 2 carbons are involved, will come to that carbon which carries more number of protons. Let's say it is CH2, over here it is CH. So which carries more protons? This carbon carries more protons. So positive part mean electrophile will attack over here. It will become CH2 and this will become Cl. So this will be the product, you got my point? The positive part mean electrophile will attack, will make bond with the carbon which has more protons, means which is less substituted. More protons, what is Markovnikov rule? More protons mean less substituted. Less substituted, less substituted. This is less substituted, Over here I can show you in this case. Let's say we have a molecule over here. It's a CH and we have CH2. This is an alkene from here to here. This is an alkene molecule. Okay. And let's say if we are going to do hydration. We are going to add water. We have an iodine water, OH is negative and proton is positive. So proton is the electrophile. Okay. So it will attack, it will make a bond with the carbon which carries more number of hydrogens. So this body is more number of hydrogens. So this proton will also come over here. So 2 protons and the one from outside, it will become CH3 and the OH will make a bond with this one. So we will have this sort of product. Okay. Look at this one. We have again hydration of this molecule. Over here what is happening? We have CH we have CH. On both cases, on both sides, the number of protons are equivalent. This is called symmetrical alkene. This is called symmetrical alkene, where the substituents are equivalent on the same side. So now you can add proton on this carbon or on this carbon. You can attach hydroxyl on this carbon or this carbon. There will be no difference. The product is the same. You need to look, you need to consider, you need to look for the Markovnikov rule when the alkenes are unsymmetrical. Means when the carbons carry unequal number of protons, unequal number of substituents. Let me take this example, and we are going to add HBr, hydrohalogenation, one of the example of hydrohalogenation, This is an alkene and it is supposed to undergo an electrophilic addition reaction. In this case, proton is supposed to act as an electrophile. So this proton will go on the carbon which carries more number of protons. Over here we can see it carries single proton. Over here this carbon carries 1, 2, 3, 4 bonds. So it has no proton with it. It carries protons, so positive part will come to it. So it will become CH and then we have CH. And the Br will be on the other side. So this will be the product. So Markovnikov rule means the positive part of the molecule. Positive part means electrophile. Let's say we have this type of alkene and we are going to react it with an alkyl halide. Okay, over here CH3 positive and Cl negative. So this is going to be an electrophile. So it will attack at carbon which carries more number of protons. Over here it carries more number of protons. It carries 2 protons, it carries 1 proton. So what is going to happen? So we will eliminate the double bond. Here is the CH3 which has come from outside as an electrophile, and the chloride will go on the carbon number 2. So this will be the product. Okay, as per the Markovnikov rule, this is how the electrophilic additions of alkenes are governed by the application of Markovnikov rule. Again, alkenes and alkynes are electron rich molecules. They have the capacity to donate electron, to give the electrons away to certain species which are electron deficient. What are electron deficient? Electrophiles are always electron deficient and they need electrons, so they can come closer to the alkenes, okay, and they can add on the alkenes. Now this electrophile can attack at carbon number 1 or carbon number 2. So what is going to happen? Where it will attack, either on 1 or carbon number 2, it will attack according to the Markovnikov rule, which means this electrophile will attack on the carbon which carries more number of hydrogens. This carries more number of hydrogens, So it will go over here, and the chloride part, the negative part, will attack on the subsequent, on the other carbon. So this will be the product. So this is all about the electrophilic additions on alkenes which are governed by the Markovnikov rule. What is Markovnikov rule? I've just explained to you. Further, the alkenes can't be the simpler ones. They can't be the simple alkenes. They could be part of certain systems like this, This is also an alkene. If you want to do hydration, water, again this alkene carries same number of hydrogen on both sides. So hydrogen can attack on this side or on this side, that is no issues, both are the same. So the product is going to be proton and over is hydroxyl group at the same, or it could be Both are the same, no problems at all. However, let's say if we have an alkene like this, and over here we have another attachment like this one, you know, this way. So in this case, now this carbon carries one proton and this carries no proton. Let's say we are going to add HCl. So this proton positive part will go to the carbon which carries more protons. So it will get added over here. Hydrogens, and over here we have a substituent from the starting, and then we will also introduce one chloride. So generally hydrogens are not written, they are understood. The product would look like this. The hydrogens are not represented, product would look like this. Hydrogens are not represented, the product would look like this. So this is all about the reactions of alkenes, the electrophilic reactions of alkenes, which are governed by a Markovnikov rule. What is Markovnikov rule? I've just explained. You need to go through the lecture. If you have any questions, you can approach me through email, or you can write down your comments in comment area on YouTube channel. So thank you very much for your kind attention and presence. Assalamu alaikum.